welcome to the deep dive. If you're one of the millions of people kind of eyeing an electric vehicle right now, you know the big three. Those psychological roadblocks that just stop the purchase cold. Range anxiety, the miserable time you spend waiting at a charging station, and that, dramatic drop in performance the second winter hits.
Yeah, they're the big ones.
Now, imagine a single technology that could just eliminate all three of those concerns in one swoop. We found this really aggressive claim in our source material, suggesting one massive manufacturer is making an all-or-nothing bet that they've found the silver bullet.
That's absolutely right, and that's what we're digging into today. This is a deep dive into the high-stakes strategic gamble being run by Dongfeng Automotive Group. They are aggressively pushing to commercialize solid-state batteries, or SSBs, and we're going to measure that next-generation chemistry directly against the current industry standard, the reliable and cost-effective lithium iron phosphate battery, the LFP.
So, our mission for you today is pretty clear. We want you to walk away understanding exactly the monumental technical leap SSBs promise and why they're being called the future of EVs. But also to assess the sheer magnitude of the strategic risk Dongfeng is taking with its, well, almost unbelievably ambitious timeline for global market disruption. Let's get into it. So, we should probably start by setting the stage with the incumbent technology. LFP batteries. They're the industry workhorse right now.
They are, especially for those high-volume mass-market segments. They are stable, they're cheap to produce, and they have an excellent cycle life. You can charge them over and over.
They're the standard for a reason.
For a reason, but they have physical limitations. And that brings us to the fundamental difference of the solid-state battery. In LFP batteries, as in most conventional lithium-ion cells, the electrolyte, that's the medium that shuttles ions between the cathode and anode, is liquid, or, a semi-liquid gel.
And what happens when you swap that out?
In the SSB, that electrolyte is replaced entirely with a solid, non-flammable material. And this isn't just an upgrade, it's a complete architectural change. It allows for the use of a pure lithium metal anode, which is the real key to all the claimed advantages. That solid electrolyte is the source of the immense performance gains, the superior safety, and the efficiency boost.
And speaking of safety, you mentioned non-flammable. What technical risk does solid state specifically mitigate? Because that's a huge deal for consumers.
It directly mitigates thermal runaway. For anyone who's not familiar, that's the rapid self-heating process in conventional liquid batteries that, once it's triggered, is extremely hard to stop and usually leads to fire.
Right.
Because the SSB eliminates that highly volatile liquid component, you just drastically reduce the chance of that catastrophic chain reaction starting in the first place.
Okay, so before we get into the crazy performance claims, let's frame Dongfeng a little. Who are we talking about here?
We're talking about a giant. Founded in 1969, one of the biggest players in China. They aren't some startup concept car maker. They have serious global ambitions, aiming to sell 1 million new energy vehicles and EVs overall.
And their sources show a very focused strategy on Europe. They want to triple their annual sales in the EU to 80,000 vehicles by 2026. This isn't just about selling more cars. It feels like it's about using technology to aggressively force their way into established markets.
Exactly.
Okay, let's look at the specs, because this is where the technical leap really becomes clear for the driver. We have to start with the most important metric: energy density.
Right. Energy density is basically how much energy you can cram into a battery of a specific size and weight. We measure it in watt-hours per kilogram, or watt-kg. And this is really the heart of the LFP limitation. A current LFP battery, it sits around, 180 watt-kg. They're heavy for the charge they hold.
So what's Dongfeng's solid-state battery target?
They are targeting 350 watt-kg.
Wow.
Yeah, that is nearly doubling the density of the current market leader. If they hit that mark, it translates directly to a massive improvement in range. We're talking over 1,000 kilometers on a single charge in a standard vehicle.
So you either get a massive range boost from the same size battery, or you get the same range from a pack that's way smaller and lighter.
And a lighter battery pack means better efficiency, better handling, and lower manufacturing costs. It's a win all around.
But the second major anxiety point is the charging time. And the claims here are, they're truly astonishing.
They are. Dongfeng claims their SSBs, when paired with their new 1200-volt platform, they're calling it the Mach Super KW Pure Electric Platform, can add 450 kilometers of range in just 5 minutes.
5 minutes. That is a refuel, not a recharge. That works out to what? 2.5 kilometers of range added every single second you were plugged in?
Pretty much.
But let's ask the technical question. Why does that 1200-volt architecture matter so much for this speed?
Well, higher voltage allows for greater power transfer in the same amount of time without overheating the system. Think of voltage like water pressure. If you double the pressure of the voltage, you can fill the tank much faster. A typical EV today is around 400 volts, maybe 800 for some high-end models.
So jumping to 1200 is a huge engineering leap.
It's a critical commitment, yeah. It's designed specifically to handle this massive power influx. And like we said earlier, the structural integrity of the solid electrolyte also means it's more durable, better chemical stability over thousands of cycles.
Okay, and finally, let's talk about that cold weather problem. This has killed EV adoption in places like Norway or Canada for years.
This is the strategic differentiator for northern markets, for sure. LFP batteries just really suffer when the mercury falls. But these SSBs claim superior cold weather efficiency. Specifically, they say they can retain over 72% capacity at minus 30 degrees Celsius.
72% at minus 30, that is massive. Our sources show conventional lithium-ion batteries often drop below 60% capacity retention under those same conditions.
That 12 or 15-point difference isn't just a number. It completely removes a fundamental barrier for consumers in cold climates.
Okay, so we've covered the potential. The tech promises to fix range, charging, safety, and cold weather. This is the definition of a game changer. So if the technology is this good, why are we talking about Dongfeng debuting it in 2026 instead of it being in every car today?
And that brings us to the strategic roadmap and the critical gap between potential and reality. Dongfeng is choosing a high-volume entry point. They're positioning the SSB tech to debut in vehicles like the compact Nami 01.
The Dongfeng box in Europe, right?
Exactly. They want to offer 1,000-kilometer range cars at mass market prices.
And their timeline, as we said, is incredibly aggressive. A commercial debut in vehicles by September 2026, a little over 2 years from now.
And here is the catch. The industry consensus among independent battery experts places large-scale viable commercialization of SSBs much, much later. I mean, we're talking 2030 is the optimistic scenario for wide adoption. Some experts even cite 2035 as the more realistic target for true mass production.
That is nearly a decade of difference between Dongfeng's promise and what the rest of the industry thinks is possible. We have to be skeptical. Why are they so doubtful of that 2026 date?
It all comes down to scale. Dongfeng's active pilot line, where they're testing this tech, currently has an annual capacity of only 0.2 GWh.
Let's pause on that. For the listener, what does 0.2 GWh? I mean, what does that actually mean in terms of making cars?
A GWh is a massive measure of energy, 1 billion watt-hours. To put it simply, a serious mass-market EV maker needs tens or even hundreds of GWh capacity every year. Dongfeng's current capacity is minuscule. It signals a massive, unresolved production bottleneck. Moving from a lab bench to reliable mass manufacturing is historically the single hardest part of battery science.
And that brings us to the other huge challenge, the infrastructure for that incredible charging speed. That claim of 450 kilometers in 5 minutes, it's based on the car being plugged into a 2-megawatt ultra-fast charging station.
It is?
How realistic is that? It sounds like a dependency that's completely outside of their control.
It's the Achilles heel of the whole charging claim. That headline figure is strictly contingent on that 2 mW infrastructure. These chargers require significant grid upgrades. They're exceptionally rare today. Dongfeng can perfect the battery, but if the station can only deliver 350 kilowatts, the battery's potential is capped.
So one of its most compelling benefits for you, the driver, remains totally theoretical until a massive external infrastructure build-out happens.
It's a leap of faith, not just in their own R&D, but in global energy infrastructure.
And this high-stakes bet is explicitly tied to their European expansion strategy. So let's zoom in on how they plan to gain a foothold using this promise.
Well, if they hit that 2026 target, it lets them enter Europe not just as another Chinese import, but as a technological leader. They're using a multi-brand strategy to cover all the bases at once. Nami for the city cars, Voya for luxury, and M-Hero for those niche, specialized vehicles, all alongside their core Dongfeng brand.
It's a segmented approach.
Right. It lets them offer a competitive product at every price point, all backed by this promise of future SSB supremacy.
And they're backing this with a rapid physical build-out, specifically targeting Italy as a key early market.
That's right. They're aiming for 7,500 to 9,000 sales in Italy alone by 2026. And to hit that, they're aggressively expanding their dealership network from around 40 today to over 100 by the end of next year. They're building the sales infrastructure now, based entirely on the promise of the revolutionary tech arriving later.
So to synthesize this whole strategy, Dongfeng is gambling. They're gambling that the promise of technological supremacy, the range, the charge speed, the cold performance, will let them leapfrog incumbents and capture market share, but only if they can somehow solve the production scaling and the 2 milliW infrastructure
The
problems.
strategic stakes could not be higher. If Dongfeng succeeds and actually hits that 2026 target, they redefine the performance benchmark for EVs globally. Every major competitor, from Tesla to the big German automakers, would be forced into a massive, immediate, and very costly pivot to solid-state batteries.
And conversely, what happens if they fail?
Well, failure to meet that September 2026 date would severely damage their credibility as an innovator. It would cede that critical first-mover advantage to rivals who are quietly building towards that more cautious 2030 timeline.
So that's the tension we'll be watching for the next couple of years. The technology is real, the potential is undeniable, but the timeline is the ultimate gamble.
And that leads us to our final provocative thought for you, the listener. Given that the current Dongfeng Nami Laura 1 is sold today with a conventional LFP battery, how much will the promise of future SSB technology influence your decision to buy a car in the next year or so, knowing the critical risk that the truly transformative tech might not actually arrive until closer to 2030 or even 2035?